improve its performance, we call it optimization. And if we change in behavioral domain from one level to another, then we call it, for example, refinement or abstraction. If we go from top views, like system level, we call it abstraction, because in top views we have very general statements about the main working of the system. If we go from general levels to detail levels, or uh, not top levels, really low levels, like circuit level, like gate level, and something like that, we have a refinement. In this refinement, we reach to the circuit, we reach to the main specifications of the circuit from some general statements. Then we call this refinement. Okay, our slide is about VHDL design process. In VHDL design process, we have some steps at first. For example, we have the architecture of the system, and by VHDL coding, we will reach to a VHDL code, a VHDL language, a VHDL file, a VHDL and description. And after this, we must simulate this code to notice that this code is right or not. Then we have another step, behavioral simulation. By some input test, we have a behavioral simulation. If we have any wrong thing, we must go back to our VHDL model and change it, and then simulate it again and check the simulation result. After this, we have another step. We call it synthesis. What is really synthesis? We get, or the software, a special software, get the VHDL code from us and check it. This software checks this VHDL code to know that this VHDL code can be implemented into FPGA or not. Because we have some VHDL codes that they are very, very general and they can't be implemented on FPGA. Then synthesis is a very main step that check our code, that check our VHDL code to see that this code can be implemented on FPGA or not. Another step is implementation. In implementation, we implement the VHDL code into FPGA. It's like a programming. In microcontroller programming, we program for example, our program in, for example, like in Bascom or CodeVision into microcontroller. In this step, we implement the VHDL code into FPGA. And after this, we can change our timing limitations, timing analysis. We can check our delays and check if they pass our limitations or not. And in synthesis, we have some sub-levels. For example, a gate level for getting the VHDL code or compiling the VHDL code and checking if it is right or not, and we can reach to some gate levels. And after gate level, we can optimize this VHDL or these gates to reach a better structure of the system. Our reference book about the VHDL is a book with this title, Circuit Design with VHDL, and its author is very famous. This book is very famous. This book is written by Pedroni and can be a very useful book for you. You can download it from internet or you can use it. It, it respects that which kind of language you are better. If you have a good language in English, you can download its English book. If not, um, you can download the lectures in English, both in English and in Persian. And the main contents um, of this term or of this lecture. After this, we want to speak about the main structure of the VHDL, the main specifications of the VHDL, and we start VHDL coding with definition of device in VHDL and the method or the way of description really. And we will speak about data types in VHDL, about different methods of modeling, for example, behavioral modeling or structural modeling. And after all, we will speak about functions, procedures, and packages in VHDL. Okay, this first lecture is ended, and we want to start the second lecture about uh, about VHDL structure. I hope that you can um, use from this uh, course to know more and more about modeling, testing, designing, and development of digital system design. Thank you very much and goodbye.